It's tough to speculate about it because there are so many individual things. Hopefully we did a good enough job designing all the parts so that they'll be robust, but we're building a robot that is as tall as I am, and a large number of the structural components are made out of 3D printed plastic. It's not the way that you would normally go about building something like this, so it's harder to estimate, and it's the first time I've designed something of that scale with that material set. So we'll see how it goes.
On Thursday, May 22nd in Pensacola, with Discovery Channel filming, we made a successful launch at 1:52 p.m. of the large HexRunner, and it went to world record speed for a robot, demonstrating stability and the concept that stability at these speeds is geometric, not a matter of traditional control methods.
So with the HexRunner project, we're trying to show that it is indeed possible to do really fast, efficient, graceful running using very little feedback. With most running and walking robots, we have a lot of sensors, and about 1,000 times a second we read what the sensors are doing, do a lot of computation to figure out what the actuators should be doing, and then send a desired current or torque or command to the actuators. And we have to do that really quickly or the robot will fall down. As opposed to that, with the HexRunner and the fast runners, everything is done mechanically, using springs and linkages. All the feedback mechanisms happen physically. So instead of having to do a lot of computation and have a lot of sensing, as you squeeze the throttle on your RC remote, it speeds up the motor, it gives more power to the motor, and just based on the dynamics and the geometry of the mechanism, the robot's stable. The HexRunner is definitely a running robot because it has legs with intermittent contact with the ground, and it has a flight phase, and it has the same energetics as a running robot. However, the legs spin around in a circle, so it looks a lot like a wheel. Well, we spin them around in a circle so it doesn't have to swing the leg forward. In simulation, we've made what we've been calling reciprocating runners that are essentially HexRunners, but with only one leg per side. So those reciprocator runners are like a HexRunner, and then if you take one more step forward and make an articulated leg, you get to the full fast runner model, which works really well in simulation, and hopefully we'll get that robot working someday. And we believe that robot looks a lot like and acts a lot like an ostrich. And so since each of these models are very similar, if you're going to say that the HexRunner is a wheel, then you have to agree that an ostrich has very similar features to a wheel too. And we believe it does. So the little HexRunner is a very robust robot. You know, we had it running for 10 miles without falling down. It's running through grass, over hills. It's pretty fast. It got up to about 24 miles per hour. One of the biggest challenges with a big HexRunner is we need to get it to about 20 miles per hour. So in order to do that, we built this pendulum mechanism that lifts the robot to about 20 feet in the air and drops it. And so we've had trouble getting a real good launch for a while. The big HexRunner on a treadmill, we were able to achieve 45 miles per hour. Now we're planarizing it with a stabilizing mechanism, so it's hard to say if that's a fair call. We've got a handful of really good runs, including the 30 mile per hour run. And so we think we can robustly launch that robot now in the future.
Hey, what just happened?
It worked beautifully, twice in a row, and the second time we hit a signpost and it exploded.
Running is geometric. Once you're fast, you're stable. And then we can save the energy and run very efficiently now. And it's not a control burden. So it just opens the doors that weren't open before for fast running, efficient robots. We're just beginning with this whole thing.